Good day, students. I hope you're all fine. Today we are starting with chapter 5, which is antiderivatives. We're in general talking about antiderivatives. Of course, we are done with chapter 4. We did lots of examples about L'Hopital's rule, about the applications of differentiation. We studied differentiation. You are already familiar with differentiation. But in this chapter, we are doing anti-differentiation or antiderivatives. That means we are thinking backwards. We don't say that if I have got f of x, what is the derivative of f of x? Now, the derivative is given to us. We have to find the function, the original function, okay? So in general, we say that f, where f is any antiderivative, is called an antiderivative of the function f on a given interval if f prime of x is equal to f. Okay, so previously what did we have? We were given a function f of x, and it was required from you, for example, if it is given to us, that's equal to x squared, and it was required from us to find the derivative of that function. Okay, f prime of x, that's equal to 2x. Simply, that's the derivative of the function. Now, what will be given to us? Now, f prime will be given to us. That's denoted as f in here. Okay, for example, f of x, that's equal to 2x. It's given to me. It is in, of course, example 1. Okay, f of x is given to me. It is equal to 2x. It says find its antiderivative. What is the antiderivative? As I told you, we are thinking backwards. Now the derivative is given to me. It's required from us to find its antiderivative. So what is the antiderivative of that function? F of x, that's equal to x squared. Why? Because this is the original function. I have got this one, and in the definition, what does it say? It says that f becomes antiderivative of that function if I take its derivative, okay, here, its derivative, and it is equal to f. Now I have got f of x, it's equal to x squared. When I take the derivative of this one, what will I get? I'll get 2x. Since the derivative of f capital is equal to f of x, so we call this one an antiderivative for the function f of x. Part B, we are given a function g of x, and it is equal to cosine of x. It's required from us to find its antiderivative. What is the antiderivative of that cosine function? What does it mean? That means we are searching for the function whose derivative is equal to cosine of x. If we look at cosine of x, we have got sine, okay? Sine of x is the original function. Why? Because when I'm taking the derivative of this one, it is equal to cosine function. So that is antiderivative. Now we are given another example, h of x, that's equal to 2x plus cosine of x. We're finding the antiderivative of this one also. H of x is equal to, what is the antiderivative of 2 of x? The antiderivative is x squared. Okay, why? Because if I take the derivative of this one, I get 2x plus, and the derivative of which a function is equal to cosine of x, that's equal to sine of x. So that's the general idea for anti-differentiation. That means we are thinking backwards. Instead of the original function be given to us, the derivative of the function is given to us, and it is required from us to find the original function. In general, antiderivatives can be written in a most general way. It is written as f of x. Okay, that's f of x. It's written as f of x plus c. Why plus c? I'll explain it for you now. Okay, why? Because, for example, if you look at that function f of x, okay, that's equal to 2x. Let's find its antiderivative. Antiderivative, okay. What is the antiderivative of this one? That's equal to x squared, as we said. Is it okay if I write x squared, for example, plus 1? instead of f of x that's equal to x squared, is it okay to write f of x that's equal to x squared plus 1? Yes, it's okay. Why? Because if I take the derivative of x squared plus 1, again, I will get 2 of x. How about if I write this one? F of x that's equal to x squared minus 1. Is it okay? Will this one also be an antiderivative for 2 of x? Yes, of course. Why? Because if I take the derivative of this one, again, I will get 2 of x. How about if I write f of x that's equal to, for example, x squared plus 1 over 2, okay? That's also an antiderivative for the function f of x that's equal to 2x. Why? Because when I'm taking the derivative of this one, I will again get 2x. So in general, if you look at here, if I add a constant to the antiderivative function, it will still be an antiderivative for f of x that's equal to 2x. So in general, instead of writing all the possible cases, 1, 2, because we have got infinitely many cases, infinitely many numbers, so we cannot write all of that cases together. We cannot describe all those cases and be written here. So instead of writing all those constant, in general, I will say that the antiderivative of that function is equal to what? I will write it here for you in general, okay? The antiderivative, let me write it here, antiderivative is equal to what? Is equal to x squared plus c, okay? So what is the antiderivative of that function? It's equal to x squared plus c. That c represents a real number, so it takes positive numbers, negative numbers, rationals, irrationals, whatever number are in the real numbers, it is considered as that number. So in general, when we are finding the antiderivative of a function, we are finding the function and we are adding a c next to it, because that c's value, when you're taking the derivative of it, becomes 0, so it will be in general an antiderivative for that given function. Now we are given another example. Example 2. As I told you, that's the general writing case of anti-differentiation. It says find an antiderivative of f of x that's equal to 3x squared that satisfies f of 1 equal to -1. So when that satisfaction is given to us, you have to also find that c that is written in here. So you will get the general antiderivative function. Now, if you look at that function, okay, let me write it for you. F of x is equal to what? Is equal to 3x squared. If I take the derivative of which function, I get 3x squared. It is easy. You know that the derivative of x to the power of 3 is equal to 3x squared. So f of x is equal to x to the power of 3. Why? Because when I take the derivative of this one, I'll get 3x squared. And I have got what? Plus c in here. Why? Because we said when we are finding the antiderivative, we are also adding a c next to it, because this one again is a general case for anti-differentiation, and that c does not make any problem in here, because when we take the derivative of it, it becomes 0. Okay, now to find that c, we have got another thing given to us. The function, the antiderivative that I have got, satisfies that condition. F of 1 is equal to -1. So f of 1 is equal to what? Is equal to 1 to the power of 3 plus c, and that's equal to -1. Okay, I have got that equation. When I put 1, it says if you put 1 into the function, this one, the antiderivative, the result will equal to -1. What do I have here? I have got c unknown, and those two are knowns. So c is equal to -1. I'm taking this one to the other side. So that will be -1. So c is equal to what? C is equal to -2. So the antiderivative of the function f of x is equal to what? Is equal to x to the power of 3. And instead of c, I will write -2. And that is the general function of the general antiderivative of the function f of x that's equal to 3x squared. Why? Because now if I take the derivative of that function, what will I get? I will get 3x squared, and this one becomes 0. That's the general idea for anti-differentiation. Now I'm going to, of course, anti-differentiation, like we have got a symbol for differentiation. We are taking the prime, we are writing those primes over the derivatives. We have got a symbol for anti-differentiation. It is called integration. Okay, so let us write the rules for differentiation. Okay, I mean for integration. So what is anti-differentiation called in general? It is called integration. And integration has got a symbol. What is the symbol for that one? We have got integration of f of x dx, and that's equal to what? That's equal to f of x. Okay, that one is the integration symbol. Okay, that is the symbol of integration. That f of x is the integrand. We are doing the operation on that f of x. We are finding the anti-differentiation of that f of x, and it is called an integrand. And that one, that x, is called what? Is called the symbol or a variable of integration. Here, when we were taking the derivative of a function, the symbol of the variable of differentiation, what was it? It was x, because we were taking the derivative of the function with respect to x. Here we are taking the integration of the function with respect to x. So x is called the variable of integration. If you have got a and b, of course, if that will be plus c. Okay, I'll get plus c, because when I'm taking the anti-differentiation or the integration of a function, I will get f of x plus c. And if I have got bounds, okay, if I have got a here and b, these ones are called, this a and b are called limits of integration. This one is called the lower limit, and that one is called the upper limit of integration. So in general, what do we have? What have we studied so far? We have studied anti-differentiation. Anti-differentiation is it's like thinking backward. Okay, we are given a function. We have to find the function that its derivative is equal to this one. Okay, and that function is called the anti-differentiation. In general, we have got a symbol for anti-differentiation. It is called integration symbol. And we are taking the integration of the function that we have got with respect to a variable x. If you have got limits, these ones are called limits for the integration symbol. Okay, this one is called the lower limit, and that one is called an upper limit. If you have got limits for the integration, we call it a definite integration. If you have got, let me write it for you. If I have got f of x dx, that one is called indefinite integration. And if I have got bounds for the integration, limits for the integration, I will call it definite integration. Okay, so I have got what? Definite integration and indefinite integration. What is the difference between those two? Here I have got limits for the integration. Here I do not have any limits for the integration. Okay, now let's move to the rules of anti-differentiation or integration. There in the course material, it is the rules of anti-differentiation. The formulas are given like the function and the general antiderivative, but I will summarize it as integration. It would be better for you even when you're studying. So we have got rules or formulas. Formula for integration. Okay, or integration formula. The first rule that we have got, the first formula that we have got is that integration of a constant number is equal to that constant multiplied to x plus c. Okay, if I have got any constant, so how will it come out? It will be kx plus c. As an example, if I have got integration, for example, of 3 dx, so I have got what? 3 multiplied to x plus c. If I have got integration of, for example, minus 3 dx, minus 3 is again a constant, so that will be minus 3x plus c. If I have got integration of e dx, e is what? It's a special number, it's 2 point something. So since it is a number, it's a constant, so that will be ex plus c. Okay, now let's move to the second rule. Okay, we have got integration of x to the power of n dx. What does that equal to? In differentiation, the power was decreasing by 1, but here the power increases by 1, so that will be x to the power of n plus 1 over n plus 1 all plus c. But here I have got a condition that n must not equal to 1. Why the n, that power must not equal to negative 1? Because if it is negative 1, here I will have something undefined. Okay, so that's why that n must not equal to 1. I mean negative 1. So in general, if we go to the examples, if I have got x squared dx, okay, that n is not equal to negative 1, so I'm applying that rule for this. I'm increasing the power by 1 over that power plus c, and that is the anti-differentiation. Or if I have got x to the power of minus 2 dx, how do I take the derivative, the integration for that function? The power is increased by 1, minus 2 plus 1 is equal to what? Is equal to minus 1 over minus 1 plus c. Of course, you're simplifying this one and you will get the required result. Now, if we have got integration of sine of kx, okay, dx, sine of a number, that will be minus 1 over that number cosine of kx plus c. Why? For example, let's do the example, it will be obvious for you. If you have got sine of 3x dx, according to this one, it's equal to what? It's equal to minus 1 over 3. Okay, that k, that is the 3, cosine of kx, that's 3x, and all plus c. Why? Because if I take the derivative of this one, what will I get? I will get sine of 3x. Now we have got cosine rule, integration of cosine of kx dx, that's equal to 1 over k sine of kx plus c. For example, if you have got integration of cosine of let's say minus 3, or let it be plus 3, okay, so that you will see the difference between this and that, dx, that's equal to what? Instead of k, what do I have here? I have got 3, so that will be 1 over 3 sine of 3x plus c. Fifth rule, I have got integration of secant square of kx dx, that's equal to what? That's equal to 1 over k tan of kx plus c. Why? Because the derivative of this one is equal to secant square. Again, for whatever k you have got here, you will put it instead of this one and you will get the required result. If you have got cosecant squared of kx dx, that will be minus 1 over k cotan of kx plus c. Why? Because the derivative of cotan is equal to cosecant square of x. The seventh one, we have got integration of secant kx tan kx all dx, of course, that's equal to 1 over k secant of kx plus c. Why? Why the result of this integration is equal to that? Because we know that if we take the derivative of that part, we will get, if you take the derivative of secant, it is equal to secant tan x. The last one that we have got for this section, we have got cosecant kx multiplied to cotan of kx dx, that's equal to negative 1 over k cosecant of kx plus c. Okay, that's the last rule for this section. Now we are given examples. Example 3. It's required from you to find the antiderivatives of the followings. So a is equal to f of x, is equal to what? Is equal to x to the power of 5. How do you find that antiderivative of this one? Antiderivative symbol is integration. That's x to the power of 5, and I'm taking the integration with respect to the variable x. So I'll put x to the power of 5 inside the integration symbol, and that will be like that. We know that integration of x to the power of 5, it is increased by 1, okay, and over the power plus c. Okay, here we had the rule, if you remember. If you have got x to the power of n, so that will be of x to the power of n plus 1 over n plus 1, whatever power I have got here, it will be in the denominator, and all plus c. So that is the antiderivative of x to the power of 5. Part B, we are given a function g of x is equal to 1 over square root of x. Again, it's required from us to find the antiderivative. Antiderivative is integration, so we are finding the integration of that function, 1 over root of x dx. This one is not a power, but we can change it into a power. How? We can change x under the square root into x to the power of 1 over 2, and if you take it to up, okay, to the numerator, it will be x to the power of minus 1 over 2 dx. Now this is a power. The power, since it is not negative 1, so we can simply add 1. So that will be x to the power of minus 1 over 2 plus 1 over minus 1 over 2 plus 1. Okay, because we are increasing the power by 1. Like we did here, we increased 5, it became 6. We are increasing minus 1 over 2 by 1. You can directly, of course, write the result, but it is okay if you do that step also. So x to the power of minus 1 over 2 plus 1 is equal to x to the power of 1 over 2 over 1 over 2 plus c. So that one will equal to, I'm putting this one to up, 2 root of x plus c. Okay? We've got the third part. We're given the function f of x. It's h of x, but doesn't make a difference. That's equal to sine of 2x. Again, the anti-differentiation is required from us. So sine of 2x dx is equal to what? Let's move to the rules that we have got. Sine of 2x. So that will equal to minus 1 over k, that is 2, cosine of 2x all plus c. Okay? The last one, part D, it's easy. You can do it yourself. You're doing the same procedure that we have done in here. Then we have got example 6. Here in the previous example, the things that were given to us were separately given, but now here a mixture of them is given. That means they're added together. Let's see how will we take the integration of something that's given all together. Of course, it is easy. Evaluate integration of x squared minus 2x plus 5, all taking the integration with respect to x. Integration is linear. What does linear mean? That means if I have got addition and subtraction between those terms, I can say that that integration is for this one, that integration symbol is for this one, and that integration symbol is also for the 5. Okay, so you can skip that step, or if you want, you can separate all of the parts, but I think you do not need it because you're already familiar with integration. You have studied this one, so skip that step and simply solve it. What is that integration equal to? Okay, the integration of x squared is equal to what? That is x to the power of 3 over 3. We increase the power and over the power, okay? Minus 2. What is the integration of x squared of x? That's equal to x squared over 2, because the power is 1. If we increase by 1, that will be x squared, and put it on the power, that is 2. Plus, if you have got a constant, we are simply adding an x next to it. I mean, multiplying it by an x, so that will be all together like that. If you look at here, we've got 2 as a common factor between numerator and denominator, so it will be x to the power of 3 over 3 minus x squared plus 5x plus c. And that's the required result. Okay. In the course material, it has separated this one because this changed like that. Let me do a simple step here. I will have it like that. Integration of x squared dx minus 2 integration of x dx plus integration of 5 dx. Okay, you can separate it like that, and the integration of x squared is equal to this, integration of that this, 5 this, but you do not need to do that step because it is already obvious. Okay, we are done with section 1 of chapter 5. Hope you have understood the subject easily. Now I will go into chapter 5 with section 2, that will give us the general idea of integration and how to solve integrations in general. Okay, how to use it, the applications of using integration.